Welcome Knife World, this is Ryan from Knife Pivot Lube. I am here today for a video that's going to be a kind of a science lesson, so buckle up. But before that, what's in the pocket today? I am carrying a Gen 6 Hinderer XM18 in brown, G10, and M390. I was a little hesitant to pick up a Hinderer before they came out with this Gen 6 designed with the tri-way pivot, but Rick Hinderer, I gotta hand it to you, this thing is awesome. The Gen 6 Hinderers come with a pivot that's meant to accept either ball bearings, phosphor bronze washers, or Teflon washers. I've actually got the bearings in it right now and they work fabulously. This thing is smooth, the D10 is tuned perfectly, and it is just a hard use beast of a knife that fits in the pocket really well. So I've got that with me. Also having a little bit of fun today with an Ultratech from Microtech. This is the double action out the front auto that is just a ton of fun to carry around and is kind of an awesome box opener and tape cutter that I love to play with. So I've got that one with me as well. Anyway, to get started, like I mentioned, we're going to have a bit of a science lesson talking about why we oil knives in the first place. What even is the purpose? We know that it makes them smoother, but what's the deal? Why at Knife Pivot Lube do we talk about protecting your pivot or protecting your knife? And there are a couple of reasons that we do talk about that. The first being that our pocket knives work in an incredibly harsh environment. If you think about something like a car engine or sealed bearings on a skateboard or something like that, the engineers who designed those devices have taken extraordinary care to make sure that dirt and grit are not getting into that engine. That's why you have things like air filters and oil filters and fuel filters, all designed to keep kind of those everyday contaminants, the dust, the dirt, out of the moving parts of that machine. Our knives have none of that for the most part. These things are open to the elements and they are picking up dust and dirt all the time. Now, a lot of that dust and dirt is things that are in your house already, things like dead skin, household dirt, household dust, which can be annoying and can make things not very smooth, but they're not very hard and certainly not as hard as the blade of your knife, that hardened steel in something like M390. But a lot of those contaminants are actually quite hard. So science lesson, again, I mentioned, we're gonna pull out, this is called the Mohs Hardness Scale, which is designed to give us a number to classify how hard a mineral is. So here we've got that Mohs scale, and it runs all the way from a number 1, which is one of the softest minerals out there, talcum, all the way down to diamond, which we all know is about as hard as you can possibly get. In the middle here are things like a knife blade, which is going to run something around a 5 or a 6 on the Mohs Hardness scale. Copper coin, 3 to 4. Your phosphor bronze is going to be somewhere in the 4 range. Now, the types of minerals that you're going to be picking up in dust in your knife are actually quite hard. Much of that sand and grit that you're going to pick up that's just out there in the world around us is going to be quartz. That's what the majority of the sand at the beach is actually made out of, is quartz. Quite a lot of feldspar, which tends to degrade into dirt and dust and sand. And that stuff just blows around in our environment. Anytime there's a dust storm or wind, this is the kinds of things that you're going to be picking up, in your backyard when you're cutting things open, in the dirt around you. These things get into your house when you track them in from outdoors. There's also a bit of topaz in the natural environment, as well as things like corundum, which would be your aluminum oxides and your aluminosilicates, which again fall in this range. All of those are so much harder than your knife blade that when they come in contact with it, and when you're operating that knife blade open and shut, they're going to actually dig into your knife blade, and particularly your phosphor bronze washers, which are going to be in this range up here. Those are going to get gouges abraded out of them. Your knife is going to become actually less smooth as you use it because these contaminants are entering your knife. Another reason that we use lubricants on our knives is because they actually seal out air, water, and salt, and those contaminants cause corrosion. And so you're going to get things developing in the pivot of your knife like rust, which is actually quite hard. Your iron oxide is going to be somewhere in this 6 to 7 range on the Mohs scale. We actually use this. This is jeweler's rouge, which you may recognize if you do any buffing or any work on jewelry. This is actually just iron oxide powder mixed with a wax carrier. And we use this to abrade metals. You know, you can actually use this stuff on a strop for some gentle stropping action. It is quite hard. And that will be developing in your knife's pivot all on its own if you're not protecting it with something like a corrosion inhibitor, something like knife pivot loop. Also, in today's work environments, you're going to be picking up a lot of things that are really, really hard on this Mohs scale. If you work in a shop at all, you may recognize things like this. This is ordinary sandpaper. Now, in the old days, this used to be made of something like garnet, which is quite hard. But nowadays, most of our sandpapers are made out of aluminum oxide, which is going to run us up into this 9 on the Mohs hardness scale. Much, much harder than a knife blade. Much, much harder than phosphor bronze washers. And this stuff is going to be wearing off of these sanding sheets as you use them all the time. Some sandpaper nowadays is actually made of silicon carbide, which is even harder and can really work its way into anything that you're working with. So if you're working in an industrial environment, if you have a home shop or anything like that, you're going to be picking up these little tiny microscopic grits all the time. All right, so what do we do about all that dirt and grit that's getting into our knife as we use it every single day? Well, the good news is you can protect your knife. And to demonstrate, I brought along some pieces of broken up brick to represent the grit and dirt that would get into your knife in everyday use. You can see that these things are really quite jagged. And as you're opening and shutting your knife blade, these pieces of grit are going to want to roll around and scratch up the metal. They're going to drag along and abrade the metal in your knife. And because these things have jagged surfaces, they're going to want to stick together and form even bigger clumps. You can see how these two, just out of friction, kind of want to stick together, and they're going to agglomerate in your knife into these nasty, sticky chunks, and they're going to roll together and try to move together and provide even more friction, preventing you from opening your knife. The good news is, knife pivot lube has ingredients that are meant to combat both of these deleterious effects of abrasives. They're going to help prevent that abrasive from digging into your knife as it's moving. They are also going to help prevent that agglomeration that holds these grits and dirt together, making them into a bigger problem, but also preventing them from moving out of the pivot of your knife as you use it. So let's talk about how knife pivot lube works. We're going to make believe apply some of this to our knife pivot simulated here and show what knife pivot lube actually does to these pieces of grit and dirt that you're picking up in your knife. Of course, on a much smaller scale, but this is a demonstration. Okay, you can see here that now that we've applied knife pivot lube to our pivot, immediately that knife pivot lube is going to wick its way into the tight crevices of your knife, and it is going to bind to the dirt and grit that's in your knife. And you can see that these red balls represent the molecules of knife pivot lube surrounding a piece of dirt or grit that was in your knife previously. Now that this has happened, this piece of dirt or grit is not going to be able to dig in to the metal surfaces of your knife. Rather, it's going to slide, it's going to roll, it's not going to be doing the damage to your pivot that it would have otherwise. Additionally, and you can imagine these pieces of grit would also have knife pivot lube coating them, but they are not going to want to bind up against each other and agglomerate in the same way. They are going to slip past each other. In the lubricant industry, we call that detergent action. Knife pivot lube has components that are meant to help promote that. And that's going to break up these pieces of dirt and grit and hold them in suspension in the liquid that's in the pivot now that you've added knife pivot lube. Once these are in suspension and they're rolling around nice and smoothly, they're going to want to exit the pivot of your knife. They're going to want to flow out of the way of the moving parts of your knife. And that's why we say knife pivot lube actually cleans your pivot as you're using it. It's going to take those pieces of dirt, those pieces of grit, and it's going to move them out of the way. Another aspect of Knife Pivot Lube's secret sauce for making your knife blade operate smoothly is the fact that it is actually a high pressure lubricant. What does that mean? That means Knife Pivot Lube can hold up and maintain a film of these molecules even around the tiny pointy parts of these pieces of dirt and grit, those little corners right there. The way we express force in the engineering world is in pounds per square inch, or the metric equivalent. And that means, say we push down on this piece of dirt or grit on this flat surface, we're going to get something like, say I'm pushing down with 10 pounds, and maybe this is 1 square inch, we're going to get 10 pounds of force per square inch. Now, if this piece of dirt or grit has a sharp edge on it, which many of them do in the real world, that 10 pounds of force is going to be concentrated on that sharp edge, and we're going to have, with 10 pounds of force, many hundreds of pounds per square inch of force on that one little point. So with Knife Pivot Lube, we want to make sure that this film of Knife Pivot Lube is going to hold up against those, massive amounts of pounds per square inch that are occurring when your knife blade is operating against those little points and sharp pieces of grit in your knife. Knife Pivot Lube has high pressure additives that are meant to prevent that film from breaking down. So even though you're working with something that's sharp, like pieces of aluminum oxide that may have come off of sandpaper, pieces of quartz or feldspar that you may have picked up in the outdoors, that film of Knife Pivot Lube isn't going to break down. You're not going to get scratching on those sharp points in the grits that you've picked up. And that's what makes Knife Pivot Lube so darn smooth when you're operating your knife. That's something you're going to be able to feel when you very first apply Knife Pivot Lube and deploy your knife for the first time. So to summarize, why do we use lubricants? Why do we oil our knives? Why do we want to use Knife Pivot Lube on a regular basis on the knives that we carry in our pockets? Number one, it's because it keeps that dirt and grit from doing damage to your pivot. The molecules of Knife Pivot Lube will coat the sharp surfaces of that contamination, that dirt, that grit, and prevent it from doing damage to your knife. Number two, Knife Pivot Lube keeps the dirt and grit from agglomerating with itself and pulls it into suspension, meaning that it holds that dirt and grit in the Knife Pivot Lube fluid. Once it's in the fluid, that dirt and grit will want to move out of the way of the moving parts of your knives. It will want to exit the pivot, where you can swab it away with something like a cotton swab. Finally, Knife Pivot Lube will seal your pivot and prevent moisture from encroaching on those metal parts. That'll prevent things like corrosion from happening within the pivot itself. As we know, the corrosion that we're producing is actually harder. The rust is harder than the blade steel. It's harder than those phosphor bronze pivots, and it will actually wear away at the knife itself. Hope you guys have learned a lot during this video. I know it's been a bit of a science lesson, but I wanted to go into some of the reasons why Knife Pivot Lube is so great and why it's got such fantastic reviews online. Thanks everyone for joining me. This is Ryan, signing off.